Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is the first video on the next chapter of operations on algebraic expressions. So this is part 1 video where I will discuss about very basics of algebraic expressions that you have already studied in your previous class and the addition and subtraction of algebraic expressions, and we'll solve some selected problems from the exercise 6a from the textbook of author RS Aggarwal. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have my quick notes on the left hand side on the topic that I will discuss in this video. I will share the link of the PDF of this quick note in the description below the video, from where you can check out the quick notes. These are some basic things that you already know and have studied in your previous class, that is class 7, about algebraic expressions. So let me first discuss something that you have already studied. So what is a literal factor? So first, I may not be exactly following the notes, but I will refer my notes to discuss the concepts that I want to discuss in this video. So you all know that what is it is about algebraic expressions. So let's say an algebraic expressions is consist of a few terms where the terms are connected by by addition or subtraction. So let's say, I am in short writing algebraic AE for algebraic expressions. Let me quickly check whether everything is visible or not. Okay, so AE stands for algebraic expressions. The format is that you will have a term 1, let's say T1 means a term 1, and then term 2, and then term 3, like this, term 4, let's say term 4. So this is the general format of an algebraic expression. So there could be like term minus term 5 and minus term 6 or term 6. So in this algebraic expressions, we see there are 6 terms, T1, T2, T3, T4, T5, T6, and they are connected by either plus or minus operations. So this is the basic format of a algebraic expressions. So let's take a specific example. Let's say we have an algebraic expression minus 4x square plus 3xy, let's say plus y square and minus 2. So this is an algebraic expressions. This is an algebraic expression where we have 1, 2, 3. We have 4 terms. That is, the terms are in this algebraic expression. The terms are minus 4 x square, 3xy, y square, and minus 2. So this is you already know that this is the basic format of an algebraic expression. Okay, now a literal factor. So literal factor means literal factor is a part of a term, and numerical factor is also part of a term. So a term, what is a term? So all these minus 4x square, 3xy, y square, and minus 2, these are all terms. Now how is a term? What is the structure of a term? So a term is a product of one or more literal or numerical factors. Now what are literal factors? Literal factor. Example are literal factors. Example are, let's say, x cube. or y square, or let's say 1 by x, or let's say 1 by z cube, or y. These are all literal factors. And literal factors is also sometimes known as variable factor, since these terms x, y, these are all variables. Now, what is numerical factor? Numerical factor means they are all constant terms like -1, or let's say 0.01. They could be integer, they could be rational number, fraction, decimal. They are constant, in general, rational numbers. So these are some numerical factors. Now, a term is a product of one or more. In general, there is one numerical factor and multiple literal factors. Let's say, so these I'm writing some examples of terms. So let's say I have minus x square, so y. So this is a term, and so a term is a product of one or more literal factor or numerical factor. But if there are more than one numerical factor, or all the numerical factors are merged, their product is considered as a one numerical factor. Okay, so minus x square y is a term. Let's say minus 5.1 y cube x cube is also a term. I can have minus 2x by z cube. These are all terms. Now okay, so these are all terms. Now let's see. So in this term, for this term, what are the literal factor and numerical factor? So let's abbreviate numerical factor as NF and literal factor as LF for the sake of discussion. Now, for the term minus x square y, the numerical factor is equal to minus 1, and the literal factor, the literal factors, in fact, literal factors are x square and y. Okay, for this one, for this term, sorry for my very weird way of using the arrows, but I hope you will understand. For this term, that is minus 5.1 y cube x cube, what is the numerical factor? In a term, there is only one numerical factor. So numerical factor is minus 5.1. And what are the literal factors? Literal factors are y cube and x cube. For this one, for this term, that is minus 2x by z cube, numerical factor is equal to minus 2, and the literal factors are x, and I can say 1 by z cube, which means z to the power minus 3. So I hope it is clear what is a term and how a term is made of product of one or more literal factors and one numerical factor. Okay, now regarding a term, we have the concept of coefficient of a factor in a term. What does it mean by coefficient of a factor in a term? Let's say I have a term minus 3 x cube y z by, let's say, u. This is a term. Now this is a term. Now as you know, for this term, the numerical factor will be minus 3, and the literal factors are x cube, y, z, and u to the power minus 1, which means 1 by u. These are the literal factors. Now for this term, what is there is a concept of coefficient of a factor in a term. So what is coefficient? I mean short writing, coefficient of x cube in this term. In this term, that is minus 3x cube yz by u, the coefficient of x cube is, you consider every other factors, that is that is both numerical factor and literal factor, except x cube. So whatever is left, if you ignore the x cube from the term, whatever is left, that is the coefficient of x cube. So it becomes minus 3 yz by u. Similarly, coefficient of y is equal to minus 3 x cube z by u. Similarly, coefficient of z in this term is minus 3 x cube y by u, and coefficient of u in this term is minus 3 x cube y z. So this is the concept of a coefficient of a factor in a term. Now what okay, next is so in the notes you can see I have example, I've made a chart where I have listed I have few terms, and for each term I have listed down the factors and the literal coefficient and the numerical coefficient. Okay, so what is for a term, what is the literal coefficient and the numerical coefficient? Okay, so now the concept is, let's say for this term only, minus 3 x cube y z by u, the numerical, this is numerical coefficient of a term, numerical coefficient which is also known as simply coefficient. So for this term, that is minus 3 x cube y z by u, the numerical coefficient or the coefficient is just the numerical factor of the term, is the numerical factor of the term. That is, numerical coefficient or coefficient of a term is equal to the numerical factor of the term. There is only one numerical factor in a term. So in this example, so if I so coefficient, let's say this term, I am denoting this term as t. So coefficient of t is equal to minus 3. So this is the numerical coefficient, which is also known as simply coefficient of a term. Now what is literal coefficient of a term? There is another concept of literal coefficient of t is everything in the term except the numerical coefficient or the coefficient. So in this case it will be x cube y z by u. So this is the, for this term, that is minus 3 x cube y z by u, the literal coefficient of this term is x cube y z by u. That is, you just ignore the numerical coefficient or the coefficient of the term. Whatever is remaining, excluding the coefficient or the numerical coefficient of a term, that is the literal coefficient of a term. Okay, now like terms and unlike terms. So what are like terms? Two terms are like if they have same literal factors. So let's say I have I have some terms, let's say minus x square y, and I have the term 4y x square, and I have the term 3 by 2, let's say I have the term y by x to the power minus 2. As you can see, these are all like terms. These are all like terms because there all these terms have all these terms all these terms all these terms so terms having the same literal factors are known as like terms. So all these terms have the literal factors equal to x square and y. All these terms, as you can see, x square y, its literal factors are x square and y. For 4y x square, its literal terms are also y and x square. And the third term, that is 3 by 2 y divided by x to the power minus 2. Now 1 by x to the power minus 2, 1. So as you can see, 3 by 2 x to the power minus 2 is nothing but 3y x square by 2, and its terms are, and its literal factors are y and x square. So all these terms have the same literal factors, so they are like terms. Whereas the terms, let's say x minus x square yx y square, these are not like terms. So these are like terms, and these are unlike terms because they do not have the same literal factors. For this term, literal factors is equal to x square. For this literal factors is equal to y and x, so it's different. And for this, the literal factors is equal to y square, so they are all different, having different literal factors, so they are unlike terms. So this is about like terms and unlike terms. What else? Okay, now we algebraic expressions. As I have already discussed in the beginning, what is an algebraic expression? Algebraic expressions is one or more terms, a combination of one or more terms which are connected by plus or minus, that is addition or subtraction operations. So in the quick notes you will see some expressions and its corresponding terms. So you must be very clear about the terms of a given expression. Let's say a given expression is minus 4 x cube plus x y square minus x y minus y cube plus 4. So this is an algebraic expression. So its terms, what are the terms of this algebraic expression? The terms are minus 4 x cube x y square negative of x y negative of y cube and 4. Now another concept is a constant term. What is a constant term? So a term which has no literal factors is known as a constant term. That is a term which has only numerical factor is a constant term. So this is a constant term. This is a constant term. Okay. What else? Now operations on terms. How do we perform addition and subtraction between terms, or multiplication and division of terms? So these are, because these are operations on terms, are the basics or the foundation based on which we do addition and subtraction or multiplication and division of algebraic expressions. So to understand how addition and subtraction of two algebraic expression works, we need to be very clear about how addition, subtraction, multiplication and division of two terms work. Okay, so addition and subtraction of like terms. So you can add and subtract like terms. So how do we add and subtract like terms? So let's say there are some like terms. Let's say minus 4 x square. So there are 3 like terms. So these are all like terms. These are like terms because all these terms are having the literal factors as x squared. So let's say we are asked to add these terms. So how do we add? So we have to add these terms. So first term is this, and then we add this, and then we add this. Okay. Now the addition of like terms will be the addition of the coefficients of the terms, the addition of the coefficients of the terms multiplied by the like terms. Since these are all like terms, each term will have the same literal coefficient. So the result of adding one or more like terms is that you add their coefficient. You add the coefficient of the terms, and then you multiply with the sum of the coefficients, multiply the literal coefficient. So as you can see, if I add the coefficients of all the terms, I get -4 plus 1 minus 1, and then I will multiply the literal coefficient of all the terms which is common, that is x square, and this is equal to minus 4 x square. So this is how we add the like terms. The sum of one or more like terms is equal to the sum of their coefficients multiplied by the common literal coefficient. In this case, the literal coefficient was x square. Let's say we want to add, my machine is giving a lot of problem. Let's say we want to add minus xy cube and y cube x by 2, and then x y cube, and we have 3xy cube. So these are all like terms where they have the common literal coefficient, which is xy cube. So we have when we add the terms, we get this. So this is the addition of all the terms. Since they are like terms, their literal coefficient is same, the result will be, we will add the coefficient of all the terms. So I have -1 plus half plus 1 plus 3, and then I will multiply with the common literal coefficient, which is xy cube. Now this is 1 cancels out, and this is 7 by 2 xy cube. Half plus 3 is 7 by 2. Okay, I hope how do we add like terms is clear. Now how do we subtract like terms? Now subtracting like terms is, the concept is that whenever we do subtraction, that is when we subtract b from a, where a and b are some numbers, or they even could be some variables, whatever. When we subtract b from a, the concept is that we add to b the additive inverse of b. Additive inverse of b, which is minus b, negative of b, we add it to a. So the same concept works in subtraction of terms. So let's say if we are asked to subtract x square plus 4 from minus 3x square minus 1 plus x. Now remember, when we so when we add okay, so this was about addition of like terms. Okay, fine. Now let's say we are asked to subtract this is about addition and subtraction of like terms. Okay, so the terms must be like terms. So this is the wrong example. So let's say if you are asked subtract 5 y x square from minus x square y. So we can see that the terms 5y x square and minus x square y, they are like terms because they are having the same literal coefficient x square y. So we have to subtract uh, 5y x square from minus x square y. So this is what we have to do. So what we do is so this is equal to minus x square y plus the additive inverse of 5y x square is minus 5y x square. So now we see it becomes addition of two like terms, and we know how to do addition of two like terms. We just add the coefficient, that is minus 1 plus minus 5, and multiply it with the common literal coefficient, that is x square y. So this is equal to minus 6 x square y. Okay. I hope it is clear how do we do subtraction of like terms. Okay. Now multiplication of terms. Remember that we just discussed about addition and subtraction of like terms. There has to be like terms. Now let's discuss about how do we multiply two terms, and they need not be like terms. So multiplication of two terms. So let's say, how do we multiply two terms? Let's say I have one term is minus 4 xy square. So let's say we have to multiply the terms. The first term is minus 4xy square. The second term is, let's say, half yx, and the third term is, let's say, 5x cube by y. Now when we multiply terms, the terms need not be like, they can be unlike terms. Now what are unlike terms? Unlike terms means they do not have the same literal coefficient. Now how do we, so we have to multiply these three terms, which means we have to perform the multiplication of these three terms. 5x cube by y. So what is the procedure? We first multiply all the coefficients of the terms. Coefficient means the numerical coefficient of all the terms. We first multiply them. That is, I have minus 4 multiplied by half multiplied by 5. So this will be the product of the coefficients of all the terms will be the coefficient of the final term result, and then we collect the same literal factors from all the terms. From all the terms, we collect the same. We group we create group of similar literal factors. Now, by similar literal factors means we group by the same literal. That is, in this example, the first term has two literals, x and y. The second term has also two literals, y and x. I am not talking about literal factors, but literals. In the third term, the literals are also x and y. So in the final result of the product, we will group all the similar literals. That is, from the first term, we consider the literal x, it is x. From the second term, we consider the literal x, it is also x. And from the third term, we consider the literal x, which is x cube. So this way, we collect all the similar literals and take their product. So if we consider the literal y from the first term, it is y square. If we consider the literal y from the second term, it is y, and from the third term, it is 1 by y. Now, if we simplify the product of the coefficients, we get minus 10, and we have x multiplied by x multiplied by x cube. By using the laws of exponents, it becomes x to the power 5. And y square multiplied by y multiplied by 1 by y, it becomes y square. So this becomes minus 10 x to the power 5 y square. So this is how we multiply terms. Let's take another example. Let's say multiply minus x y cube, and this is the first term. The second term is let's say 20 y by x square, and let's say 0.5 minus 0.5 y square by x, and z, let's say z. So these are the terms, three terms. Let's take another term. Let's say 3z cube by x y. So there are four terms. We have to find their product. So the first term is minus xy cube multiplied by the second term is 20y by x square. The third term is minus 0.5 y square z by x, and the fourth term is 3z cube by x y. So the concept is, first we find the product of all the coefficients of the terms. So we have, from the first term, the coefficient is minus 1. The second term, the coefficient is 20. The third term, the coefficient is minus 0.5. And the fourth term, the coefficient is 3. So this will, the product of all the coefficients will be the final coefficient of the result. And we have to multiply them. We have to make groups of all the similar literals. Now, if we consider the literal x from the first term, if we group all the x literals from the first term, I get the literal x. From the second term, I get the literal 1 by x square. From the third, I get the literal 1 by x. And from the fourth, I get the literal 1 by x. Similarly, we have to do it for the other literals, that is y and z. So from the first term, we get y cube. From the second term, we get y. From the third term, we get y square. And from the fourth term, we get 1 by y. Now for z. Z is only in the third term and fourth term. In the third term, we get z, and in the fourth term, we get z cube. Okay. Now, if we simplify the product of the coefficient is we have minus 60 into minus 0.5 multiplied by minus 60. So this becomes 30. So 30 is the product of all the coefficients. Now, if we multiply all the x literal factors, we get x by x to the power 4. X by, so 1x cancels, x by, so it becomes 1 by x cube. 1 by x cube multiplied by the y literal factors becomes y by cancels y to the power 5 and the z becomes z to the power 4. So this finally becomes 30 y to the power 4, y to the power 5, z to the power 4 divided by x cube. I hope it is clear how do we multiply two terms. Now the division of terms is very similar. Now division of terms. The division of terms is that, let's say we have to find minus 3x square y. This is a term divided by, we have to divide the term minus 3x square y by, let's say, xy. So as we know, the division operator, if you divide a divided by b, of course b has to be a non-zero number or a variable. A divided by b is nothing but is equal to a multiplied by the multiplicative inverse of b. So b to the power minus 1 is the notation of multiplicative inverse, which essentially is 1 by b. So this becomes minus 3 x square y multiplied by 1 by xy. Multiplicative inverse of xy is 1 by xy. So this is equal to minus 3 x square y divided by x y. Now you group the similar literal factors together. So minus 3 is the, so this is minus 3 multiplied by x square by x and multiplied by y. So this becomes minus 3 xy. No, this was y by y, so there will be no y factor. So this is minus 3x. So this is basically how we do the division of two terms. You must be well aware of the laws of exponents. Okay, so this was division of terms. In the quick notes you can see more examples. Now let's come to addition of algebraic expressions. So we are given two algebraic expressions. How do we add them? So the steps are: collect the like terms from the algebraic expressions. Collect the like terms, add the like terms, and leave the unlike terms unchanged. So this is the three steps of doing addition of algebraic expressions. Now I will explain this through example by solving problems from exercise 6a. Now how do we subtract two algebraic expression? So let's say E1 and E2 are two algebraic expressions and we have to find E1 minus E2. So E1 minus E2 will be E1 plus the additive inverse of E2. The additive inverse of E2, which is minus E2. So minus E2, now minus, what does minus E2 means? Minus E2 means you just negate all the terms of E2. Negate all the terms of E2. For example, let's say to understand, so if we have E1 minus E2, where E1 and E2 are two algebraic expressions, so this will be equal to E1 plus the additive inverse of E2, additive inverse of the algebraic expression E2, which is negative of E2. Now what does it means by the negative of a algebraic expression? So let's see. Let's say I have an algebraic expression. So let's say let E is an algebraic expression 4x cube. I am taking a very basic example. Let's say this is a algebraic expression E. This implies what will be minus E? Minus E will be minus of 4x square minus xy plus 1. So this is how we express the negative of a expression. Now how does So we put a parenthesis, we put the entire expression in a bracket, and then before the bracket we write a negative sign. Now, how does the negative sign before the bracket affect the algebraic expression? So when we open the bracket, all the terms of the expression gets negated. That is, if they are if the sign changes, so this becomes the sign. So 4x square becomes minus 4x square, and the minus xy becomes plus xy, and plus 1 becomes minus 1. So this is what it means by the negating all the terms of the expression e. So the terms, so as you can see, terms of e was 4x square minus xy and 1. So terms of minus e will be minus 4x square. You just change the sign of each term, and xy and minus 1. Okay. So this is how we do subtraction of algebraic expressions. So now let's solve few selected problems from the exercise 6a. Let me quickly check if you can see the exercise 6a problems. I hope the fonts are big enough and you can see it properly. Okay. Let's solve some few problems from 6a. So addition, so we have to add. The first problem is, let's do one or two very simple problems and a few harder problems. So add 8ab minus 5ab. So these are all now the terms. Okay, now these it has asked to add. Now 8ab is an algebraic expression. This is not a terms. I mean, an algebraic expression having a single term. And we have 3ab and minus ab. As we can see that these are basically a single term and they are like terms because they are like terms. These are all like terms with literal factor, literal coefficient rather, with literal coefficient with, as we know that all like terms have same literal coefficient. The literal coefficient is AB. So we have to do 8AB plus minus 5AB. So basically these are all terms. 3ab, and these are all like terms. So this is what we have to do. We have to add all the given terms, and all the given terms are like terms. So how do we add like terms? We add all the coefficients, that is 8 plus minus 5 plus 3 plus minus 1, and then we multiply it with the common literal coefficient, which is AB. Now, if we simplify the addition of all the coefficients, it becomes 3, 6 and 5. So, this is 5AP. Okay. Let's do problem number 3. We have been asked to add the algebraic expressions 3a minus 4b plus 4c. This is the first algebraic expression. The second algebraic expression is 2a plus 3b minus 8c, and the third algebraic expression is a minus 6b plus c. Okay, so we have to do we have to add all these three algebraic expressions. The first algebraic expression was 3a minus 4b plus 4c. The second algebraic expression is 2a plus 3b minus 8c, and the third algebraic expression is a minus 6b plus c. Now, how do we do the addition? First, we open the brackets, but we have to be very careful. Since these are addition of all algebraic expressions, before the brackets there will be only addition operation. So when we open a bracket and there is a addition operation plus sign before the brackets, we can simply open the brackets. So when we open the brackets, we have 3a minus 4b plus 4c plus 2a plus 3b minus 8c plus a minus 6b plus c. Now we collect all the like terms together. So we group all the like terms. So let's say if I group the terms having the literal coefficient a, I have 3a, I have plus 2a, and I have plus a. Now if I group all the like terms where the literal coefficient is b, I have minus 4b plus 3b and minus 6b. Similarly, for c we have 4c minus 8c plus c. Now we have grouped all the like terms and we know how to add like terms. So this will become 3 plus 2 plus 1a plus minus 4 plus 3 minus 6b, and we have 4 minus 8 plus 1c. So this becomes 6a minus 7b, and we have minus 3c. So this is the final result, final expression of the sum of the given three algebraic expressions. Okay, let's do now. Whenever you when you are adding algebraic expressions, you first group all the like terms and you add the like terms and you keep the unlike terms unchanged. You do not, if there are unlike terms, you leave it as it is. Let's do 6. So the algebraic expressions are 2x cube minus 9x square plus 8. So this is the first algebraic expressions we have to add. The second algebraic expression is 3x square minus 6x minus 5, and the third, there are four algebraic expressions. Okay, so the first one was 2x cube minus 9x square plus 8. The second one was 3x square minus 6x minus 5. The third one is 7x cube minus 10x plus 1, and the fourth algebraic expression is 3 plus 2x minus 5x square minus 4x cube. So there are four algebraic expressions, we have to add them. Now since these are addition of algebraic expressions, we can simply open the bracket. This is 2x cube minus 9x square plus 8 plus 3x square minus 6x minus 5 plus 7x cube minus 10x plus 1 plus 3 plus 2x minus 5x square minus 4x cube. Now we will group the like terms. Let's group all the terms where the literal coefficient is x cube. So we have 2x cube and then we have plus 7x cube, and then we have minus 4x cube. Now let's combine or the group the terms, like terms, with literal coefficient of x square. That is all the x square terms. We have minus 9x square, we have plus 3x square, we have minus 5x square. Now let's group all the x terms, that is all the like terms whose literal coefficient is x, and we have minus 6x minus 10x plus 2x, and then finally we will add all the constant terms, that is a term where there is only a numerical factor, and they are 8 minus 5 plus 1 plus 3. Now if we add the terms, like terms, we get 2 plus 7 minus 4 x cube plus minus 9 plus 3 minus 5 x square, and then plus minus 6 minus 10 plus 2 x, and finally we have the constant term as 4, 12, 7. Okay. Now I might be doing some silly mistake in addition and subtraction of numbers. I'm not really focused in that. I hope you will understand. So this is 9 minus 4 is 5. This is 5x cube, and we have minus 9 plus 3 minus 5, which is minus 14 plus 3, that is minus 11 x square, and we have minus 6 minus 10 plus 2, that is minus 16 plus 2, that is minus 14 x, and we have plus 7. So this is the final result of addition of all the given 4 algebraic expressions. Let's do. So while I am doing the solving the problem, you can pause the video and take a screenshot for your future reference. Okay, let's do problem number 8. How many term expressions are there? 1, 2, 3. There are 3 algebraic expressions. The first algebraic expression is 4x square minus 7xy plus 4y square minus 3. And then the algebraic expression is 5 plus 6y square minus 8xy plus x square. And the third algebraic expression is 6 minus 2xy plus 2x square minus 5y square. So since these are addition of algebraic expressions, we can simply open the brackets and we get 4x square minus 7xy plus 4y square minus 3 plus 5 plus 6y square minus 8xy plus x square plus 6 minus 2xy plus 2x square and minus 5y square. Now we have to group all the like terms. Let's group the x square term, that is all the like terms having the literal coefficient x square. We have 4x square, and we have plus x square, and we have plus 2x square. Now let's group all the xy terms, that is all the like terms having the literal coefficient of xy. So we have minus 7xy, and we have minus 8xy, and we have minus 2xy. And finally, let's group all the y square terms. We have 4y square plus 6y square minus 5y square, and the last we group all the constant terms, that is minus 3 plus 5 plus 6. Okay, now when we add the like terms, we get for the x square terms we get 4 plus 1 plus 2 x square. For the xy terms, we have minus 7 minus 8 minus 2 xy. For the y square terms, we have 4 plus 6 minus y minus 5 y square, and the constant term is 11 minus 3, that is 8. Further simplification gives 7x square minus 17xy plus 5y square plus 8. Okay, so this was about addition of algebraic expressions. Now let's do some problems in subtraction of algebraic expressions. Let's do, okay, you can take a screenshot. Let's do problem number 9. We have to subtract 3a square b from minus 5a square b. So basically we have to subtract 3a square b from minus 5a square, so b. So we have to find this. Minus 5a square b is a term and 3a square b is another term. We have to basically subtract the term 3a square b from minus 5a square b, and we can see that these are okay. So now the first bracket, we have to open the brackets. The first bracket will open as it is, because before the brackets there is no negative sign, it is positive. So it opens as minus 5 a square b. Now the second bracket will open, the second bracket. Now we can, I think it is more understandable if we do like this. So we know, we can see that minus 5a square b is a term, and 3a square b is also a term, and they are like terms. So this will be minus 5a square b positive plus the additive inverse of 3a square b, that is minus 3a square b. Applying the concept that a minus b is equal to a plus additive inverse of b. So now if we open the brackets, we get minus 5a square b minus 3a square b. We see that these two are are like terms, and we know how to add like terms. This becomes minus 5 minus 3 and a square b, which is equal to minus 8 a square b. Okay, let's do problem number 13. We have to find, we have to subtract 2a minus 5b plus 2c minus 9. This is an algebraic expression. We have to subtract this algebraic expression from another algebraic expression, and which is 3a minus 4b minus c plus 6. Okay, so we have to so this is equal to 3a minus 4b minus c plus 6, and now subtracting. So there are two ways of finding the subtraction of two algebraic expressions. The one way is that using the concept of a minus b is equal to a plus additive inverse of b. So this will be this plus the additive inverse of the algebraic expression 2a minus 5b plus 2c minus 9. So additive inverse means we have to put a negative sign in front of the entire algebraic expression. So this is equal to 3a minus 4b minus c plus 6. Now, what is the negative of an algebraic expression? As I have already explained, that when you find the negative or when you negate an algebraic expressions, all the terms, the sign of all the terms changes from plus to minus and minus to plus. So the algebraic expression will become, when we negate the algebraic expression, the 2a minus 5b plus 2c minus 9, it will become minus 2a plus 5b minus 2c plus 9, because we just change the sign of the terms, change the sign of these terms. So this algebraic expression, the terms were 2a minus 5b, 2c and minus 9. And if you change the sign, 2a will become minus 2a, minus 5b will become 5b, 2c will become minus 2c and minus 9 will become 9. Okay. Now we have the addition of two algebraic expressions. We can simply open the bracket. 3a minus 4b minus c plus 6 plus, not plus, sorry, minus 2a plus 5b minus 2c plus 9. Now we have to group all the like terms, and we have 3a minus 2a, and we have minus 4b plus 5b, and we have minus c minus 2c, and we have 6 plus 9. Okay. So this becomes a, and then becomes b, and then becomes minus 3c and becomes 15. Okay. Let's do problem number 15. Problem number 15 is asking, so we have to subtract basically one algebraic expression from another algebraic expression. The problem number 15, we have to subtract 3x cube minus x square plus 2x minus 4. We have to subtract this algebraic expression from the algebraic expression x cube plus 3x square minus 5x plus 4. Okay. Now instead of doing the additive inverse of an algebraic expressions, you can also directly do that in one step. So you have to just now open the bracket, the first algebraic expression, before the bracket there is no negative sign, so it will open as it is. So x cube plus 3x square minus 5x plus 4. But in the second algebraic expression, before the brackets we have a negative sign. So what will happen is, we will open the bracket, but we will negate, change the sign of all the terms of the algebraic expression. So 3x cube will become minus 3x cube, minus x square will become plus x square, plus 2x will become minus 2x, and minus 4 will become plus 4. Okay. So now we will collect all the like terms, and we have x cube minus 3x cube, then we will have x square, that is 3x square plus x square, then we will have the x terms, that is minus 5x minus 2x, and then we will have the constant terms, that is 4 plus 4. So this becomes minus 1. So this becomes 1 minus 3x cube plus 3 plus 1 x square plus minus 5 minus 2x plus 8. So this becomes minus 2x cube plus 4x square minus 7x plus 8. Okay, now I will not do the similar kind of problems. I hope you got the idea and you will be able to solve the other problems. I will rather solve the what problems. So it is given so question number 18. Question number 18 says that what must be subtracted from what? So there is an algebraic expression 3a square minus 6ab minus 3b square minus 1. So it is asking what must be subtracted from the algebraic expression that must be subtracted. I am denoting it with a question mark. What must be subtracted so that the result is 4a square minus 7ab minus 4b square plus 1. Now let's, instead of question mark, let's say the algebraic expression that need to be subtracted is e. Now it is very similar. How do we solve? Let's say we have a minus x is equal to b, where x is some unknown variable and a and b are some numbers or constants. How do we find a? From here we know that this implies x is equal to a minus b. Similarly, we will say that this implies e is equal to 3a square minus 6ab minus 3b square minus 1 minus 4a square minus 7ab minus 4b square plus 1. So now we have to find the algebraic expression that need to be subtracted is basically the subtraction of these two algebraic expressions. Okay. So this is a subtraction of two algebraic expression. The first algebraic expression will open, the bracket will open as it is because there is no negative sign before the bracket. So we have 3a square minus 6ab minus 3b square minus 1. But the second algebraic expression, before the bracket we have a negative sign. So the bracket will open, but all the terms inside of the algebraic expression will change their sign. So 4a square will become minus 4a square, minus 7ab will become plus 7ab, minus 4b square will become 4b square, and plus 1 will become minus 1. So now we will group the like terms. We have 3a square minus 4a square, and we have minus 6ab plus 7ab. We have minus 3b square plus 4b square, and we have minus 1 minus 1. So this becomes 3 minus 4 a square plus minus 6 plus 7 ab plus minus 3 plus 4 b square, and we have plus minus 2. So this equals minus a square plus ab plus b square and minus 2. Okay, let's do problem number 19. It says that the two adjacent sides of a rectangle are 5x square minus 3y square, and so the two adjacent sides of rectangle means the length and breadth. So let length is equal to, the algebraic expression is 5x square minus 3y square, and the breadth let the breadth be the other algebraic expression, that is x square plus 2xy. It is asking find the perimeter. So perimeter is equal to 2 into length plus 2 into length plus breadth. For a rectangle, the perimeter is 2 into length plus breadth. So this is equal to 2 into uh, length is 5 x square minus 3y square, and breadth is the algebraic expression x square plus 2xy. So this is equal to 2 into, we can open the brackets because these are addition of two algebraic expressions, and we get 5x square minus 3y square plus x square plus 2xy. Okay, now we add, for the algebraic expression inside the bracket, we add the group the like terms, and we get 5x square plus x square, and we have minus 3y square and plus 2xy. So this is equal to twice into 5x square plus x square is 6x square, we have minus 3y square plus 2xy. So this is equal to, if you multiply, so we have 2 multiplied by an algebraic expression. So basically using the distributive law of multiplication over addition and subtraction, this will become 2 will get multiplied with each of the terms of the algebraic expression inside the bracket. So this becomes 12 x square minus 6y square plus 4xy. Okay, let's do the problem number 20. Problem number 20. The perimeter of a triangle is perimeter. Let's say perimeter of a triangle is given to be 6p square minus 4p plus 9. Okay, and two of its sides are, let's say, two of its sides. So let's say side A is equal to, the sides are given in terms of algebraic expression, also the perimeter. So the perimeter is given in terms of an algebraic expression which is 6p square minus 4p plus 9, and two other sides are given which are also in terms of a algebraic expression. So let's say side A is equal to p square minus 2p plus 1, and let's say side B is equal to 3p square minus 5p plus 3. Now it is asking find the third side of the triangle. So we know that perimeter P will be equal to the sum of the three sides of the triangle, that is A plus B plus C. We have to find C where A and B are given. So this is equal to, we have 6p square minus 4p plus 9. So this is this implies that p square, A is p square minus 2p plus 1, and B is 3p square minus 5p plus 3, and we have plus C is equal to 6p square minus 4p plus 9. Now we can say that from here, we can say that if we simplify on the left hand side, if we simplify the addition of the two algebraic expression, it becomes, we can open the brackets by p square minus 2p plus 1 plus 3p square minus 5p plus 3, and we have plus c is equal to 6p square minus 4p plus 9. Now on the left hand side, if we simplify the algebraic expression, we by adding the like terms, we get p square plus 3p square. Now I am skipping some steps. I am not showing the grouping of the like terms. I am straight away finding the addition of the like terms. So p square plus 3p square is 4p square. 2p minus 2p and minus 5p is minus 7p, and 1 plus 3 is 4. So we have this plus c is equal to 6p square minus 4p plus 9. So this implies c will be equal to 6p square minus 4p plus 9 minus 4p square minus 7p plus 4. So this is now subtraction of two algebraic expressions. So the first algebraic expressions, the bracket will open as it is 6p square minus 4p plus 9, and the second algebraic expression, the bracket will open but it has a negative sign in front of it. So all the terms of the algebraic expression inside the bracket, their sign will change. So my 4p square will become minus 4p square, 7 minus 7p will become plus 7p, and plus 4 will become minus 4. So now we have to again do group the like terms and add them. So we have 6p square minus 4p square, that is 2p square. We have minus 4p plus 7p, that is plus 3p, and we have plus 9 minus 4 plus 5. So this is the final result. So this brings to an end of solving some selected problems from exercise 6a to illustrate the concept of addition and subtraction of algebraic expressions. Now addition and subtraction of algebraic expressions you have already done in your previous class 7. So I think it was already known to you, but anyway, for the sake of completeness, I solved some problems and also discussed the concepts of how do we add and subtract two algebraic expressions based on the addition and subtraction of like terms. So in the next part, I will discuss about how we multiply and divide algebraic expressions. I hope this video was beneficial to you. If so, then please like it, share it with your friends, and also please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So please stay tuned for the next video where I will discuss about how we multiply and divide algebraic expressions. Thanks for watching, and until the next video, take care and bye.